What is bandwidth in signal modulation? Imagine trying to fit a song into a small box or a large one. In signal modulation, that box is called bandwidth, and it tells us how much space a signal takes up in the frequency spectrum. Think of it as the width of a highway lane that a signal travels on. The wider the lane, the more cars, or in this case, data can go through at once. When a signal is modulated, its frequency content spreads out over a certain range. This range is what we call bandwidth. It is measured in hertz, which is simply cycles per second. In analog signal processing and modulation techniques, bandwidth is very important because it shows how much of the spectrum a signal uses. When we take a baseband signal, which is the original information like sound or video, and modulate it onto a carrier wave, the resulting signal spreads out around that carrier frequency. The amount of spread, or the bandwidth, depends on the type of modulation used. For amplitude modulation, where the strength of the carrier wave changes to encode data, the bandwidth is twice the highest frequency in the original signal. For example, if the original sound has frequencies up to 5,000 Hz, the amplitude-modulated signal will need about 10,000 Hz of bandwidth. That is because the signal creates two sidebands, one above and one below the carrier frequency, each carrying part of the information. Frequency modulation and phase modulation are a bit different. They change the frequency or phase of the carrier wave to encode data. The bandwidth for these types depends on how much the carrier frequency varies and the highest frequency in the original signal. These modulation methods usually need more bandwidth than amplitude modulation because they can encode more complex information. Bandwidth also affects how many signals can be sent at the same time without interfering with each other. If the bandwidth is wider, more data can be transmitted faster. But it also means using more of the spectrum, which is a limited resource. Engineers often measure bandwidth using the 3 decibel point, which is where the signal power drops to half of its maximum. This helps in designing filters and communication channels that keep the signal clear and strong. Understanding bandwidth in modulation helps us build better radios, televisions, and digital communication systems. It guides us in choosing the right modulation technique and spectrum allocation to make sure signals stay clear and data flows smoothly. Whether it is sending a voice call or streaming a video, knowing how bandwidth works makes all these modern miracles possible.